Yeah, here we go. So last time we finished off talking about we were learning about pointers and dereferencing and add the address of operator, and then we kind of saw how making a pointer and dereferencing was like the same symbol, which is annoying, but it is what it is. But of course, it's context sensitive, and I always like to remember, like, well, no, I'm creating a variable that's a pointer type. So like the star goes when you're declaring the variable. And then if you have a pointer, I got to dereference. Well, that's when you add the star to the variable name. That's how I remember it. It's like, well, I'm creating something of a specific type. I'm declaring it now. So that means I'm making it the pointer. And then if you ever forget, because I always used to forget, wait, which one's dereference? Is it the ampersand or is it the star? I can't remember. I would always forget. And the trick I used, you can use it, obviously, you can do whatever you want, but for me, I'm like ampersand, address, you know, they both start with A. So that's how I thought of it. But we'll pick up where we stopped last time. We were seeing how the address of and dereference, they're like inverse operations. They allow us to like undo the address of operator, which is kind of funny, right? Because like in the examples I was showing, I'm going to actually just switch to that right now. There we go. In the examples here, like this is ridiculous. Like no one would do this in reality. Like this is ridiculous. Why would you get the address of and then immediately dereference it and then get the address of the thing you just dereference and then dereference that and so on and so on and so on? This is silly, but we can do it. And a lot of computer science is, well, here are the rules. What can we do? So it's just another example of that. Why is that last line? I think it's a different font size, so it fits on the line. Anyways, so this is actually what I think we ended on. We created a variable, made it an integer pointer type, and then immediately assigned it the address of wherever my variable was. Then I took the variable foo, but I dereferenced it. So, foo, that's the address. And then I say, no, don't tell me what the address is. Tell me what's in that address. Like, what's there? And then I mean, in this case, it's not telling us what it is. It's saying like, okay, go inside that memory address and then put in the value 35. And if we print out my var, we should see 35. Whoop. So quiz, what should be printed out here? 35. Why? Well, we actually changed my var through the address of where my var is and dereferencing it. Again, kind of undo operators. Well, here we got ampersand and then we undid it with the star. Now here is a funny example, and I think I have pictures. Oh, shoot, I don't. Come on, why don't I have pictures? I must have drawn them last year. Okay. We've got first value is 5, second value is 15. I think, let me see. How do I draw? Here we go, perfect. So we've got, oh man, how do I? Okay, perfect. I want a pen. So we've got, I'll draw a box. You can see this, right? Raise your hand in the chat so I hear the boop if you can see this. Perfect, okay. So first value 5, second value 15. So this is what we got. And then suddenly we go and create two more variables, P1 and P2. Okay, so I'll just draw boxes for them. These have some memory addresses. I don't know what they are. The computer will figure them out. But here we have P1. And here we have P2. God, it is hard drawing with a mouse. In fact, someone has stolen my bamboo pad. So, all right. And immediately I'm saying P1 is the address of first value. So whatever memory address this is, let's say it's memory address 1 million. 1 million goes inside here. So it would be like 1000000. But you know what? A lot of times when just drawing these things, for simplicity, we just draw the arrow that gets us to the, what was that? Undo, damn it. All right. We just get the arrow. We just usually draw the arrow of like which memory address, just for simplicity. So this is what we've got right now. P1, it's a memory address. So it's like the pointer to the box that is FV. It's not pointing to the 5. It's the box itself, that memory address. and P2 similarly for second value. And then what am I saying? I'm like, okay, well, P1 star is equal to 10. So we go to P1, but we dereference it. So it's not the box, it's what's inside. So we go, no, you become 10. Great. Now I'm saying, okay, P2, all right, so P2, but it's the star P2, so it's not this box, it's the value inside, 15. But then we're saying, no, you're not 15 anymore. I'm assigning you what's in P1. So P1 star is, okay, go to the box and then inside the box. And what's inside P1, the dereferenced P1? Well, it's 10. So if this 15 should become 10. Stop me if I make a mistake, by the way. And then all of a sudden I'm saying P1 equals P2. Okay, so in this case, we just copy over the contents of P2 into P1. But there's no star here, no star. Meaning that suddenly P1 gets assigned whatever's in P2. And what's in P2 is, so this disappears. This disappears, and it suddenly just becomes, why is it doing that? That's funny, my mouse is crap. What did I hear? I heard a boop. The address for, that's exactly what it is. P1 becomes the address of SV. Absolutely, you're absolutely correct. So P1 just makes a copy of this, which is an arrow that just gets us to here. So we just draw an arrow that gets us to there we go. And then all of a sudden I'm saying P1 equals 20, but of course it's not P1, it's, okay, go to P1, it's this box, dereference it, okay, and then suddenly, what? My mouse sucks. I guess this is what happens when you use a 12-year-old mouse. And then this becomes 20. Trust me, there's a 20 in there. In fact, let me change my color. 20. Okay, that's not, oh my God. Well, anyways, there we go. Now, if I come along and ask you what's first value, what is first value currently? Well, it's still 10. Because FV, well, it holds 10. Second value, well, that's now 20. What do we see? Sorry, I didn't quite get how they became 10. All right, well, we'll do this again because this is hairy. Wouldn't it be more like P1 pointing to P2 than P? No, not quite. P2, so I like what you're thinking. You are definitely thinking in pointers. That's really good. That's like the first step of getting this stuff. But can I undo all this? Oh, how do I go away? I'm literally going to do this all over again. Erase. I'm going to do this all over again with more colors to hopefully make things a little bit better. But I see some other questions. Oh wait, never mind. It's because it's just the equals, never mind. Exactly. If I had said, give me the add, if this line right here said P1, I want you to be equal to the ampersand P2, that would be like we're asking for a pointer to that pointer. But the problem is that actually would be incorrect syntax because P1 is an integer pointer, not an integer pointer pointer. I know. All right, let's start again. And I'm going to try to get a little bit better with which colors I'm using. So let's start with, not that. Let's start with red. So we've got FV. We're just going to do this one line at a time. And there's our box. Pardon me. That holds the first value. And then, oh shoot. Second value. There's the box. And what are we putting inside? Well, I'm putting in 5. And over here, we've got 15. Okay, so far so good, right? Nothing crazy. By the way, if at any point you're going, whoa, wait, what? Type in the chat, put your hand up or something, because that's when we'll figure it out. And I can guarantee you, if one of these parts is confusing you, it's confusing half of the class. So far so good. Now, right here, int star P1 star P2, well, that's saying create 2 integer pointers called P1 and P2. So we'll go back to, nope. Come on, give me my pen. Let's go back to red. We got P1, and here's its box. P2. And here's its box. And what's inside of these? Well, these are, well, here we just declared them. So this line of code ran, the second line of code ran. And this is where we are. There's nothing really important in P1 and P2 right now. It's just whatever happens to be in those boxes, but we haven't put anything in there yet. Then all of a sudden I'm saying, okay, first value, what address are you? And then whatever address it is goes inside P1. And we like to draw that as a star. And then down to P2, we say, okay, second value, tell me what your address is, because we've got that ampersand there. So it's the address of this. So we go to. Notice that the arrows, and I'm drawing this specifically in a certain way. I'm drawing it so the arrows are pointing to the boxes, not the values inside the boxes. Remember, the box is like the memory. 15 is the value inside the memory address, okay? So, ask a question now if there's a problem. Otherwise, I'm going to assume we're okay up until this point. Okay, I don't see any questions, but definitely do just say something in the chat when the time comes. All right, so now we are going to this line right here, the star P1 equals 10. So let's start. Oh, I find it easier to think through when you imagine that the P1 and P2 are holding the hexadecimal inside the box. Well, there you go. Okay, so you know what? I'm going to do it two ways. I'll say like OX0, oh my gosh, 10, okay? So this happens to be memory address 16. What 010 is 16 in hexadecimal. So this is actually holding 0x. The 0x are like that. That's like that means this is a hexadecimal number, not a decimal number. 0, 1, 0. Okay, great. And then over here, this happens to be. My mouse is crazy. 1, 0, 0. And then that means really inside of here, we actually have 0, 1, 0. Cool. Nope. No. I did that wrong. 0. Okay. 1, 0, 0. Okay. Oh my. Bear with me and the horrible mouse. I'll have to switch my mouses around for next time. So here's our current situation. Now we are saying, okay, P1. Okay, well that's right here. But we said the star. So, oh, okay. So that means like go to the memory address, but I don't care about the memory address. The star means go inside. Go inside the box. And inside the box, you're going to put 10. So we are going to go here, and this 5 is going to become 10. There we go. Why? Well, because we said, okay, go to P1, but dereference, so and go inside the box that this gets us to, and make it 10. So far, so good? Now, this is where things get weird. Because we're saying, okay, P2. Okay, here's P2. But dereference it. Okay, so we're talking about inside the box here. Okay? And we're going to assign a new value. And we're going to assign, well, P1 star. Well, what's P1? Well, here's P1, but we dereference it. So it means go inside the box. And what's inside P1's, the thing that P1 points to's box? Like, ultimately, first value. Well, currently it's 10 because we just set it to 10 right here. Right here, we set it to 10. And then here, we're just basically copying over the contents of this to here. Now, here's where it gets really kind of confusing. Sorry, let me rephrase that. Here's where you're liable to get tripped up, but it's not too bad. Because suddenly I'm now saying P1, okay, you're equal to what's in P2. Okay, so this suddenly disappears. I'm scribbling this out. I don't care. I mean, FV still is that memory address, 0x010. That should be a 0x. I typed this all wrong. So because we did int star, those variables will always be pointers. Absolutely. Their type is integer pointer, not integer. You're absolutely correct. See, you're all getting it. And then, okay, but here's where it gets weird. Again, not weird. Here's where you may get tripped up. P1 equals P2. Well, so here's P1, and here's inside the box. And what are we going to put inside P1's box? Well, P1's box holds, our P1's box is now going to be equal to P2. Well, what's P2? Well, P2 is 0x100. That's what it is. So now this is effectively doing that. So P1 and P2 both get us to second value, at least the address of second value. The contents of P1 and P2 in this example is going to be the hexadecimal number 100. So that's where we're at right now. And then all of a sudden, lastly, we're going to, let me just, where'd my mouse go? So we did that, and then lastly, we're gonna go along and grab black now, I guess, and we're gonna make one last change. We're gonna say, okay, P1, go inside the box that you point to. Okay, that's right here. And inside of that, put the number 20. There. So now, first value is still 10. We left it alone. It got left alone. Second value is now 20. Just note that this example that I'm showing you right now is, again, for demonstration purposes. It is deliberately being, I don't want to say weird, because this is absolutely valid code. It's absolutely correct, and you could do this. But one would typically not be doing this. This is just showing you kind of like, here's what you can do in like an abstract sense. Like, here are the rules, and here we are following the rules. What's the result of following the rules in this scenario? In practice, this is weird, right? This is doing all this right here. Like, you wouldn't do it this way. Like, why would you possibly do it this way? Suddenly you're just changing. Like, why wouldn't you just say first value is 10, second value is 20? There, done. Why are you doing all this crap? Honestly, just because I wanted to show you. Just so we got an example of how all this is working. But ultimately, if I was writing this code, I would just say 10 and then 20. There, problem solved. So if this part was like, okay, I guess I get it, but holy moly, don't worry about it. It doesn't matter too much. It's just, if you get it, good. If you get it and you're uncomfortable though, like, why would you do this? You're right, you wouldn't do it this way. This is weird. And in fact, those of you that are coming to lab today, I mean, those that were in lab yesterday got an example of us doing very weird, funny things with pointers that you really shouldn't do, to the point that Visual Studio will get mad at you about you. It'll let you do it, but Visual Studio is going to say, something weird's going on, because we're explicitly doing weird stuff with pointers that we have no business doing, but we're doing it because we're allowed to, just to play around. This is a good way to learn stuff in computer science. It's like, well, here are the rules. What can I get away with? I heard boops. It helps to be able to see it one step at a time and draw it out. Well, there you go. Good. So if this was the lecture hall, I'd be drawing on the whiteboard. And you know what? I really need to get, someone's borrowing my like drawing pad thing. And they've had it for like a year. I need to get that back. And then I should be able to draw a little bit nicer than I am with my mouse. You know what? I'm going to change my mice right now, because this, okay, maybe not right now. I'll change it for next time, but this mouse is giving me a little bit of trouble. Okie dokie. What's printed out? Well, there we go. Okay, pointer versus dereference. These mean two entirely different things. It just so happens that they share the symbol. Yeah, I heard something. You can borrow mine if need be for the lab. No, I've got one right here. Disconnect something. Did I mute myself for a second? Well, anyway, oh, hello? Am I back? Okay, I'm back. I touched something and it went, no, that was me. When I picked up my mouse, I touched my USB thing and it disconnected my mic. So yeah, I've got another mouse. It's just this one I'm using is ancient. Your face is still frozen. Uh-oh. It is, isn't it? Ah, it's because the USB thing I touched messed up. Okay. I will turn off the camera and then turn it back on. It's scary. All right, let's see if this is fixed. Okay. I'm going to try... discard. I'm going to try to fix this right now. Give me 1 second, because yes, this is clearly problematic. Hello? 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 Why is this stuck like this?
Hello.
Okay, I should not be stuck. But for some reason, OBS has me kind of messed up. So I'm going to actually stop recording the lecture. I'm going to exit OBS and then restart, because you're right. This is kind of a terrifying situation. So pardon me for a moment.